Hi everyone, this is teacher Tianshi from Think Academy, and welcome to our second day of practice problem. And today we are going to talk about the exponent calculation. So first of all, let's review some of the important concepts for the exponent calculation. So the first one is multiplication of properties of exponent. So the first rule is called the product rule. So the product rule equals to a to the power of m times n to the power of n equals to a to the power of m plus n. So if the two exponents, they have the same base but different exponent, we need to add up the exponent. So this is the first rule, the product rule. And the second rule is different from the previous rule because this is the power of the power. So in that case, a to the power of m to the power of n equals to a to the power of m times n. So for example, if 3 to the power of 2 and then to the power of 3, it equals to 3 to the power of 2 times 3, which equals to 3 to the power of 6. So this one is different from the product rule because this is the power of the power. And then we also have the last one, which is the power of a product. So in that case, the base is no longer one number or one variable. It is the multiplication of two different number of variable. So in that case, a times b to the power of m equals to a to the power of m times b to the power of m. So for example, 3 times 5 to the power of 6 equals to 3 to the power of 6 times 5 to the power of 6. So this is very similar to the distributive law of multiplication, but in that case, this is the power of a product. So this is the first concept. And the second concept related to the division property, and also some of the special cases such as the zero and also the negative exponent. So for the division property, we have one rule which is called the quotient rule. So if we have two exponents that have the same base and we need to divide them, so for example, a to the power of m divided by a to the power of n equals to a to the power of m minus n. So for example, if we have 6 to the power of 6 divided by 6 to the power of 3, it equals to 6 to the power of 6 minus 3, which is 6 to the power of 3. Okay, and we also have the power of a quotient. So this is very similar to the power of a product. So a divided by b to the power of m equals to a to the power of m divided by b to the power of m. So for example, if we have 6 divided by 7 to the power of 6, it equals to 6 to the power of 6 divided by 7 to the power of 6. So this is the division property, and we also have the zero and also negative exponent. So the zero exponent is very easy to remember. So any non-zero number raised to the power of 0 equals to 1. So for example, like 6 to the power of 0 is 1, and 2023 to the power of 0 equals to 1 as well. So any non-zero number raised to the power of 0 equals to 1. And we also have the negative exponent. So this is very challenging, and we need to remember it. So when calculating a negative exponent, we need to create a fraction and put the exponential expression in the denominator and make the exponent positive. So what does it mean? So if the exponent is negative, so for example, a to the power of negative n, we need to create a fraction, which means that we always have 1 over something. And then we need to make the exponent positive, which means that we need to have the opposite of it. So a to the power of negative n equals to 1 over a to the power of n. So for example, if we have 2 to the power of negative 7, it equals to 1 over 2 to the power of 7. Okay, so that's all for the rules. And let's go over to challenging questions in the homework. So the first one, so negative 1 to the power of 2023 minus 1 minus 1/2 divided by 4 times negative 3 to the power of 2 minus negative 2 squared. So let's do the calculation step by step. So negative 1 to the power of 2023. So the negative is at the front. So 1 to the power of 2023 equals to 1, right? So this is different from negative 1 to the power of 2023 because negative and 1, they are not like in a combo. So this means that the opposite of 1 to the power of 2023, it equals to negative 1. And the second one, 1 minus 1/2 equals to 1/2. And then divided by 4 and times. So this one is negative 9. And this one, negative 2 to the power of 2. So this is an even exponent, which means that the result is positive. So negative 4, and then do the calculation. So it's negative 1/2 times 1/4 times negative 13. So here, negative 1 minus 1/8 times negative 13. So it's negative 1 plus. So two negatives, they become a positive. So the final result will be 5/8. So that's for this one. And let's go over the next problems. So for this one, you can see that the exponent is no longer a number, but the exponent become a variable as well. But no worries, we can still apply the exponent rule. So for example, we can also use the product rule, the quotient rule to do the calculation. So for the first one, so first step, we can do the multiplication. So two different exponents, but they have the same base. If we multiply them together, we should use the power rule. So for the power rule, so we should keep the base and adding up the exponent. And we also have the second step. And then we can like do a simplification for the previous, for this one. So it equals to m plus 1 and then divided by x minus y divided by x plus 1. So here you can see that the two numbers, like they are exactly the same. So two exact same number like divide by each other, the result will just be 1. So the whole thing, like the very complicated exponent calculation, they can simplify to 1. Okay, so we will go over the last question. So for this one, we know that like 2 to the power of x equals to 4 to the power of y plus 1, and 27 to the power of y equals to 3 to the power of x minus 1. Then we need to find the value for x minus y. So in that case, here you can see that the base are different, right? So we cannot find the relationship for the exponent directly. But actually, we can find some relationship between like 2 and 4, as well as 27 and 3. So actually, 4 equals to 2 to the power of 2, right? And what about 27? So 27 equals to 3 to the power of 3. So in that case, we can rewrite the first one like 2 to the power of x equals to 4 to the power of y plus 1. And we can rewrite 4 in the form of 2 to the power of 2. So we can use the power rule here. So 2 to the power of 2y plus 2. So the two numbers, they have the same base and the value is same, which means that the exponent should be same as well. So x equals to 2y plus 2. And what about the second one? So for the second one, 27 to the power of y equals to 3 to the power of x minus 1. And 27 can be rewritten in the form of 3 to the power of 3. So we can do the calculation. So use the power rule as well. The two numbers, they have the same value and same base, which means that the exponent should be same as well. So here, actually, we have two value, so two variable and also two equations. So we can solve this system of equations. So x equals to 2y plus 2, and also 3y equals to x minus 1. So actually, we can use the substitute method. So we can substitute the value for x in the second equation. So 3y equals to 2y plus 2, and then minus 1. So 3y equals to 2y plus 1. So y equals to 1. So the value for y equals to 1. And what about the value for x? So x equals to 2y plus 2. So the value for x equals to 3, right? 4. So 2 plus 2 equals to 4. And then we need to calculate what is the value for x minus 1. So x minus y equals to 4 minus 1, which is 3. So the value for the last one equals to 3. Okay, so that's all for our day 2 practice, and I'm looking forward to your day 3 homework. Bye, guys.